move on then to our 12:30 talk. That would be with Jeremy Penner, talking about Honeylisp.
Hello, KansasFest. Let me just share my screen. How's that looking for everybody? Hello?
Looks great.
Great. So hi, my name is Jeremy Penner, and I'm here to talk about a thing that I built called Honeylisp. Honeylisp is kind of difficult to give an elevator pitch for, but basically it is a bunch of small tools that integrate together that I built to develop an Apple II game, kind of basically from the assembler on up. The Lisp in the title is a Lisp dialect called Fennel, which is a fairly kind of young language. It actually compiles down to Lua, which is usually thought of as kind of an extension language, but is actually like a really powerful kind of dynamic scripting language with a lot of really strong capabilities. So basically, instead of thinking of Honeylisp as like Lisp running on an Apple II necessarily, you could maybe think of it more as like a Lisp machine for developing Apple software. Kind of the basis of it is the text editor called Light. Light is written entirely in Lua. Again, Lua is kind of an extension language, so it kind of has to have like a base runtime. Light has a base runtime, which is very simple, kind of draw rectangles, draw text. And I was able to port it to a different Lua game framework called Love 2D. And so, yeah, so the Honeylisp includes an assembler written in Fennel. Built on that assembler, I built it's like a stack machine, kind of a lisp-inspired runtime on the 6502, and various other tools and capabilities, which I'll be showing off. Kind of the thing to wrap your head around maybe is that this is not a command line driven. Everything is running from inside the editor. And that's kind of interesting for reasons that I'll get into more detail shortly. This presentation is running in Honeylisp. So this is actually Honeylisp right now. You can see this is the editor. This is the source code for the presentation. So this is the particular slide. So all of these tools can kind of interact and extend off each other. So I'll be taking advantage of that as kind of we go on. So kind of the project that I wanted to drive this was a game called Newt Tower. It's a small puzzle adventure game. It's actually a port from a game that I built in kind of 2020 for DOS, which again, I'd taken a slightly different approach of building everything on hardware, working directly, and kind of building everything on Forth. In Honeylisp, I'm kind of using, I'm seeing what I can do with more modern tools. So to kind of demonstrate, I want to give a little demo of this game, so you can kind of see, get some context. And in order to do that, I'm going to do a magic trick. So when I hit the key to advance the slide, that's actually going to run the code to assemble the game from scratch. And then it's going to boot MAME, which is truly a wonderful, powerful emulator for Apple II stuff. It's going to make a connection to MAME, and then it will basically write directly to RAM and then launch it. So there's no disk image involved in this at all. It is all running kind of over the network. So here's the Apple II, and then here's the game. So the premise of Newt Tower is that you are this young woman. Her name is Jay, and she's kind of trapped in her office building. And she has to kind of get the assistance of a program that she wrote called Newt to kind of help out. So we can kind of switch between, with the space bar, controlling Newt versus controlling Jay. Newt can kind of open doors for Jay. And then Jay can kind of go over here, turn on other terminals. And then Newt is able to kind of travel through the network to get to other places and kind of help each other out. So that's just kind of the very basic premise. Kind of as it goes on, it adds more twists and turns to the mechanics. But that's basically Newt Tower. So what exactly is going on here? So I give kind of an overview, but I was very much inspired by a KansasFest talk from 2016 by Dig and Brock, where he described an infrastructure for GS Plus, where he wanted to build kind of emulator front ends that were separate from the debugger front end. So he basically he wanted to expose all of the, base functionality, reading, writing memory, registers, setting breakpoints, kind of all this stuff over the network. And I thought, well, that's really interesting, but what if instead of a debugger, I used that for, if I had a tool that kind of integrated with that, like what could that enable? I ended up, instead of using GS Plus, using MAME. And specifically, one of the things that's super powerful about MAME, which was not covered in the Ample talk, but is really, really interesting. It's not very well documented, but MAME has actually a plugin system based around Lua, which is very helpful for me using this Fennel language, which compiles to Lua. And in a MAME plugin, it exposes everything. Like I said, reading, writing memory, reading and writing registers, setting breakpoints, clearing breakpoints, continue, like anything you can do from, basically exposes the entire guts of the system. You can, send keystrokes as it was doing. So it turned out to be really nice to leverage that. There was an already existing library called Gija, which basically exposes a Fennel REPL over a network. So I was the amount of code that turns this into a MAME plugin is like half a page. Basically just like start a server and go. So I was able to kind of take this library, which is kind of meant for embedding in your program. And suddenly I'm able to send Fennel code directly kind of over the wire to MAME and then have it run. So I have this general purpose plugin that lets me take over MAME from inside Honeylisp. And kind of what then, kind of the superpower of running everything inside the editor, instead of, I have an assembler and it writes out a file or like a few different files, and then I have to have another program which like reads that and parses it back out. Instead, when I assemble my program, I have basically a full rich, Lua object, which means like I can keep alongside of it the whole symbol table. I can keep metadata around. I can kind of build off that for various other purposes. So that, and I can just have this available to all the other tools. It's literally like one line to just be like, get me the latest assembled version of this thing. So like I have like a command in the editor that's, if I'm over a symbol, I can hit Alt A and it'll show me the address of that symbol. And I can go in the MAME debugger and, look at the memory, what's happening there. I kind of am able to have all these small integrations very cheaply. Kind of another thing I want to show off was hot code reload. So I wanted to have the ability, once we have this tight integration, I know what the data is the last time I built it. I can make changes to the code or any part of it, generate a new version, and then I can kind of do a diff, or like I'm able to mark an area of memory as, this is data that should be preserved when I upload a new version of the game to MAME. So I'm just going to do a quick demo of that right now. So, and just like 5-second run through on Fennel syntax. So like normal Lisps, if you start a function call, we'll start with the parenthesis, and then the first thing inside the parenthesis is the name of the function. So like if I'm looking at the say here, what this say function actually returns is basically a data structure that is, it's almost like a macro, right? Like it's a function that just returns the code to generate. So we've got this parenthesis, so it's calling this function. Every time you see a colon here, you see it quite a lot. At the beginning of a symbol, that's the Fennel syntax for like a Lisp symbol. You can really think of it, it's really literally just a simpler syntax for a string that just doesn't have a space in it. So it's just this one prefix thing. But in this case, it's the symbol for, the portrait for the character that I want to show. And then here's what Jay is saying when I bump into that terminal. So instead I can change that to say, hello, KansasFest, to forever. And then what I can do then is just hit a key press, Alt-L here. And then I'll tab back, and what you'll see here is the debugger is going to pop up here. There's going to be a breakpoint, and then the map redrew. So the reason, the characters still stayed in the same place. So all the doors have closed, all the switches have turned off, and the reason that's kind of a trade-off where very often the thing that I want to change is the map. So I'll want to push the new version of the map. But the game actually keeps some of the state in the map itself. So, I have other ways to kind of get around that. I have cheat codes to walk through walls or something like that if I want to test something out. But yeah, this what happened there is the breakpoint that got hit was basically a sync point that I define in the code kind of at the top of the game loop, where we know it's safe to stop, move everything around and resume from there. There's nothing, no data on the stack. We're not in the middle of any kind of, tricky operations or anything like that. We can stop the CPU. So, we're not going to, while we're in the middle of writing memory, run into, overwrite the next instruction with some garbage and crash the game. So we're able to kind of do that all safely. And I will demo the change that I made. Hello, KansasFest. So yeah, that was a kind of code change on the fly. So that's how that kind of all goes down. Kind of the next thing was, so this is in the background here of the slide. You can see this is the setup that I had for developing the original new tower for DOS. The large PC is a 286 with it actually has 4 megabytes of RAM, but I only use 640K because that's so much RAM, as this crowd knows for sure. But then I have a second machine on top of that, which is a Toshiba T3100E, which is also a 286, but I'm using it kind of basically as a dumb serial terminal. And this picture was actually taken in February 2020 at the Global Game Jam, which was the last time I got together with a whole bunch of people in the same room doing nerd stuff. But yeah, this is I did everything kind of on hardware. And one of the things that I did for that was I built the game. I built a fourth system that was kind of running at all times. It handled the control of stuff, but it also, the game was defined in fourth. But I also had kind of this interactive debug terminal for running commands and, interactively trying things out while the game was running and interacting with it in that way. And that was really valuable and was something I kind of wanted to make sure would work. So ordinarily, how I would normally be doing this is I would be in a text editor and I would just write this stuff and then hit a hotkey. I've put it into just buttons for convenience here. So I can run the word that is mixed. So that switches to mixed high res and text mode. Here's just a little piece of code that pushes 1 on the stack, pushes 2 on the stack, adds the top 2 numbers together, and then dot prints it out. If you're familiar with forth, this is very obviously going to print 3. And then I have the ability to, this fetches the address of the J's location on the screen. And then get will dereference that pointer and get the value there, and then dot will print it out. So I can see here, J is at Y coordinate 4, X coordinate 1. It's printing in hex because I'm just using the monitor routines. And I can move J around while the game's running and then call that again. Now it's different. So I'm able to interactively, kind of ask questions and do things. I get insight without necessarily needing to go directly to the Apple, the MAME debugger. And also, as I'm, cycling through things, as an example, say I was messing with the earthquake sequence and I wanted to run that again. Okay, well, here's the intro part again. I don't need to reset the game and set up the state and get everything going. I can just directly, ask to do the thing that I want to test. So yeah, that's a really useful kind of feature that was definitely good to have. So of course, developing a game isn't just code. There's a lot of useful and interesting data, and there's a lot of better ways to write it than writing text. So kind of the first useful thing is we have a tile editor. Here's kind of all of the new tower is basically just built up of tiles. This is virtually all the graphics in the game, just combined in different interesting ways. But you can see here's Newt. You can kind of figure out what that looks like animated. Here's J, 4 directions, the floor, the terminals, the sky. And I can just kind of scribble along this to make changes. And that you can see it updates over here. These things at the side, that controls kind of the last bit that controls the palette for, this is kind of 2 bytes. Every tile is 2 bytes wide, so that they can tile easily. I can just copy and paste the data directly into RAM when I'm drawing. And each tile also has these flags. So Newt is able to go through the walls, so the wall is Newtable. J is able to walk around the floor, so the floor is walkable. And these are all defined in code. And there's obviously 2 different tile sets for when if you're in human mode or if you're in program mode. So there kind of needs to be copies of things. And copy paste works. So, if I wanted to paste over the cloud or something like that, I can do that. So it's pretty nice. I actually, gave this to my 13-year-old son, and he drew a bunch of different weird objects for a different project, which you'll probably see a little later. But it's kind of a nice intuitive way to draw little tiles on the Apple II, and it was it helped a lot in making sure everything looked good. Another thing that I needed that I built from basically the same code for the tile editor is, obviously I need a font. Didn't want to do mixed text graphics mode because I wanted the portraits, as you saw, beside, to define who was speaking. So then that meant I needed to draw a font. So I drew a font, and I made a little editor for drawing fonts. And it's basically just the tile editor, the exact same thing, except it's, 7 pixels wide instead of 14. And it just draws the character that should be there next to it. And if I wanted to add lowercase support, I just need to start drawing more things and then it'll show up. I actually, at one point, used lowercase letters in the game to point to random memory and just draw glitch garbage to the screen. So that's kind of a fun trick. And then again, we have all the different portraits. I'm particularly pleased with the trick I used for Jay's green glasses. They're literally just the palette bytes. I thought that was kind of fun to be able to do. And again, this is like four bytes wide instead of 2 bytes wide, so it's a little bit bigger. And then kind of the most useful tool and kind of the most involved tool is the map editor. So kind of as you can see, here's the first level of New Tower again, and you kind of have all of the different tiles available. And like, yeah, I can draw that, I can fill this room with sky or whatever. And like, that's nice as far as it goes. And that I had that, in DOS with my fourth system, but I really didn't have a way to kind of take it to the next level and to find, where the objects were in the level, the custom behavior that needs to happen. The way I did it when developing New Tower for DOS is I would literally write down coordinates on a piece of paper for like, okay, this is this particular terminal. It connects to this other terminal, C1, C2, C3, something like that. Give them these arbitrary names, and then I'd have to quit the game, go to fourth code, go to my editor, write the fourth code to kind of define them all. And then like go back and test, okay, is this everything? Did I actually write these coordinates down right? Is this doing the right thing? So instead, because I have a lot more capability at my disposal, now I have this object editor. So like if I can click on this object, it kind of outlines in purple here. And this is like the word that runs to handle the event. So I can define that off in code. So that's a switch. And then if I hover over it, you can see like there's a line that it connects to the, what it's linked to. So that switch controls that door. And if I wanted to control that door, I can just, create a new object there, drag it up, and now, change that connection. So you can see like these terminals connect to each other. This switch connects to that door. This switch connects to that door, all that kind of stuff. And like if I have any kind of custom code for a particular thing, so like, that's just door right here. You can see this is first door because when I bump into it and it's closed, J has a little kind of tip. It's like, oh, this door won't open, and just to kind of give the player, some context about a little push in the right direction to be like, okay, I need to figure out why this door won't open or some way to open this door. So yeah, I think that's more or less all. There, you can have up to 32 objects on a map. That basically each object is, I think, 8 bytes, so that fills up a page of memory. But yeah, all of this data is just saved in a big old JSON file, basically, that has all of this metadata. And then Fennel code, I use Fennel code to basically transform that JSON file into, here are the bytes that need to exist, in memory to make this map actually function. And I guess kind of lastly, the last tool that I built was this full screen image editor. Here's the title screen. There's this special splash screen that shows up when you win the game. This is kind of a really weird approach, but it was good enough to kind of get the job done. Basically, it's every kind of your cursor, whenever you're drawing something, moves horizontally 2 pixels. So like I would get these weird fringing effects that I wasn't expecting necessarily, but it just kind of, I don't know, it just kind of worked out. I think it looks okay, seeing some of the other talks, the other things that people are doing in Apple II graphics, I would definitely do something to make things be able to have a lot more texture if I was doing, redoing this. Okay. Getting a little short on time. So one of the other things, I wanted to not just have this quick workflow for editing the game. I also wanted it, for building these editors, because this is a huge amount of work to kind of build these tools to make the game. So one of the things that Honeylisp is able to do is, this is the code for the map editor here. And if I want to change, and basically the UI, it's an immediate mode GUI system, just a very simple one that I built. And so every frame, it just draws the entire UI again. So if I just like change the color of the background here and hit Alt-R, then that does a hot code reload of the editor. So like I can make changes to, whatever. I can move everything over 100 pixels, any kind of weird graphical issue or, anything going on. I can very quickly kind of tweak and make improvements too. And of course, the downside to that is if I write a bug and I hit reload and I hit a compiler or something like that, then I actually am really stuck. I can't bring Honeylisp back. I'll have to like do a git stash or open up a different editor to actually fix the bug so that I can get going again. So that's something that would definitely stand to be improved. I know I'm 5 minutes, but I really wanted to quickly show off kind of this last bit. So Bitsy, this is the second thing that I built with Honeylisp. I call it 8Bitsy. Bitsy, you can see in the background, it's a web-based game making tool for you have little characters that can kind of wander around a world and bump into things and have little conversations. There's maybe a very small amount of state that happens. But it's just kind of making chill little spaces to kind of wander around in. I built this in kind of 10 days for the Spring Lisp Game Jam. And I was just, the thought was, could I make my tools a little less kind of programmery? I'm not really sure why it didn't load there, but so like if I open up my map editor here, you can see this is the wood, obviously the level, and I can wander around here. I can bump into the cat, and the cat says he's a cat. And what that looks like in the map editor now, instead of it being, I have to edit some code to make this happen, is we kind of have some very simple commands. So like I can, and just multiple steps. Like instead of say something, I can, warp the player to a different location. I can move the player on top of the object. I can make the object disappear. I can set a flag. This is just like the list of flags that are kind of in play. That you can like, if this is like a condition, so this step will only run if this flag is set. And I can, and one of the things that's kind of nice here is, I can go to the tile editor, I can add a new thing here, just like some kind of like, I don't know, like a 2, maybe like an infinity symbol, something like that. And then it shows up immediately to like drop in. And then, I can make it have some behavior. Maybe the charismatic frog says, thank you, KansasFest, something like that. And then again, I can just hit Alt-L, hot code reload. I can bump into it. Thank you, KFest. So yeah, that's and that's, this is again kind of a multi-screen, kind of wander around, see the different maps, different places you can go, different things you can do. And it's just really fun to kind of mess with and play with, and just trying to make something a little bit more accessible. Anyway, I am almost out of time, so thank you very much, KansasFest. If you play through New Tower, you will be personally greeted at the end screen. So yeah, any questions? Oh no. Oh, okay. You
don't see anything in the chat right now. Is the editor available for download somewhere?
Yes, all of the source code is open. It's on this bitbucket.org/spindlyq/honeylisp. Literally up to the mid, like all this presentation, all the source code is completely available. Anyone can start playing with this. I think really this is only run on my laptop at this point, but if people are interested in playing around with it, I'm very open to helping out and answering questions and getting people going.